Same idea on the bottom one, but we want to know now how long it's going to take her to type a 7-page article. So I'm just going to continue my double number line that I had going. I know that I remember the ratio is 1 to 4, but I'm not going to fill in all those other ones. I'm going to skip to where I left off. And it was 5 pages in 20 minutes, pages to minutes. Okay, so now 5, 6. Remember my constants times 4. So 6 times 4 is 24. 7 pages, that's what we want to know. 7 times 4 is 28. So it will take her, it will take Emmeline 28 minutes to type 7 pages. Xavier can swim at a constant speed of 5 thirds meters per second. So 5 meters in 3 seconds. What is the ratio of the number of meters to the number of seconds? 5 to 3. Xavier is trying to qualify for the national swim meet. To qualify, he must complete a 100-meter race in 55 seconds. Will Xavier be able to qualify? Why or why not? So another tool we learned about is ratio tables. So let's do a ratio table for this one. So we're comparing meters to seconds. So in 5 meters, he can swim in 3 seconds. 5 to 3. So we want to know if he can complete a 100-meter race, how long that's going to take him. Because he only has 55 seconds. So let's see if it'll take him 55 seconds. So to get from 5 to 100, we need to multiply by 20. If we want an equivalent ratio, we do the same thing to both numbers. 3 times 20 is 60. So it looks like it'll take Xavier 60 seconds to swim 100 meters. He only has 55 seconds, so he can't do that. So no, he won't qualify because it takes Xavier 60 seconds to swim 100 meters. So he's not going to qualify. He can't swim it in 55 seconds. So in part C, he's also attempting to qualify for the same meet in the 200-meter event. To qualify, Xavier would have to complete the race in 130 seconds. Will Xavier be able to qualify in this race? Why or why not? So same ratio, 5 to 3. But we want to know now, how long does it take Xavier to swim 200 meters? So I know the same rule. What do I have to multiply 5 by to get 200? So can you guys think right now, what do I multiply by? Well, I know 5 times 4 is 20. So 5 times 40 is 200. Same thing to this side. In order to get an equivalent ratio, I multiply by 40. So 3 times 40 is 120 seconds. And he has 130 seconds to do it. So yeah, he can do that. He can, Xavier will qualify because it only takes him 120 seconds to swim the 200 meters. Okay, and our last problem today, number 6, the corner store sells apples at a rate of $1.25 per apple, or $1.25 per apple. What is the ratio of the amount in dollars to the number of apples? So dollars to apples, 1.25 to 1. Okay, since we're talking about dollars, we can also read that as $1 25 cents to 1 apple. A Kia is only able to spend $10 on apples. How many apples can she buy? So I'm going to do another double number line on this one. If you guys want to follow along and draw that as well, we'll do it together. Get a little more practice on those double number lines. It's a really great way to model your thinking if you're working with a small quantity like 10. So we're comparing dollars to apples. So it's $1.25 for 1 apple. I can see my constant. I'm multiplying by $1.25. Oops, no, arrow's going the wrong way, guys. I'm taking this number, multiplying by $1.25, so you get that number. So for 2 apples, 2 times $1.25, or add another $1.25 to this one, and we get $2.50. To kind of skip ahead, do you guys remember this shortcut? I can just double both of these, so 4 is $5. And I could do the same thing again, because she's got $10. So 8 apples. You buy 8 apples for $10. Because that's how much she has to spend right there. Christian has $6 in his wallet and wants to spend it on apples. How many apples can Christian buy? So I can use the same tape or double number line here. I know again the ratio is $1.25 for every 1. We're always multiplying by 125 as we go up here. So let's see, for 4, I'll leave off, this is kind of close to $6. So we figured out that he could buy 4 apples for $5. Can he buy 5 apples? What's $1.25 more? $6.25. So, ooh, he's only got $6. He does not have enough to buy 5 apples, but he does have enough to buy 4 apples. So 4 apples for $5. Well, I should say Christian can buy 4 apples for $5. He needs another 25 cents to buy 5 apples, but he doesn't have enough, so he can only buy 4 apples. That is our lesson today, lesson summary. A rate of 2/3 gallon to minutes corresponds to the unit rate of 2/3 and also corresponds to the ratio 2:3. Remember what we talked about in the beginning though? We could have different rates that would still correspond to this unit rate. For example, if I double these and get 4.6 gallons to minutes, that rate, along with that rate of 2/3, would both give me a unit rate of 2/3 because that's how it's going to reduce down. It also corresponds with the ratio 2/3. All ratios are associated with a given rate are equivalent because they have the same value. Value is reducing it to its lowest possible form. And when we want to find the unit rate of some object, we would actually be dividing these. So like dividing 2 divided by 3 to get the unit rate of if we want it in a quantity. Like if it asks how many miles per hour or how many words per minute, we would actually go through and do the division. So it usually involves a decimal place most of the time.